In this lesson, we want to talk about solving trigonometric equations with half angles. All right, so let's start off with a very easy example. So we have the sine of beta over 2 is equal to the square root of 2 minus the sine of beta over 2. We have a little domain restriction, or you could say you're solving over an interval. In this case, it's from 0 to 2 pi, with 0 being included, okay? Now, I want to make something perfectly clear. You are solving for beta, okay? So you want to plug something in here for beta, so basically here and here, and you want the result of this to be true, okay? You are not, in the end, solving for beta over 2, but we need to use beta over 2 in order to get a solution, okay? So what we're going to have to do, and let me write this down here, I'll show you, we need to basically change this up just a little bit, and I'll explain why. So let me rewrite this real fast. I'm going to say that I have the sine of beta over 2 is equal to the square root of 2 minus the sine of beta over 2. Okay, so the first thing I'd want to do is get that trigonometric expression by itself. And in order to do that, I'm just going to add the sine of beta over 2 to both sides of the equation. Okay, so that's how I'm going to get things started. So let me scroll down just a little bit here, get some room going. And I'm just going to show this cancels over here. So sine of beta over 2 plus sine of beta over 2 is 2 times the sine of beta over 2. And this equals now the square root of 2. Okay, if I want to isolate this completely, I'm multiplying this by 2. Okay, so I can just divide both sides by 2, and then I'll take care of that. So I'll divide this side by 2 and this side by 2. And basically, this is going to cancel with this. Okay, so that's gone. And I've isolated the sine, and let me make that a little bit better. So it's the sine of beta over 2. So that's on my left side. On the right side, I have the square root of 2 over 2. Okay, so let's pause for a minute. I'm actually going to erase all this. And let's think about what we have. We have this right here, which is beta over 2. And we have the sine of that guy. And we're saying that it's equal to the square root of 2 over 2. So before we start thinking about how we're going to solve this, let's first modify our little domain to work with what we're working with here. We're working with beta over 2. So I'm going to write this as an inequality. I'm going to say that 0 is less than or equal to. I'm going to do this beta guy here, which is less than 2 pi. Okay, because that's what we're initially working with. Again, this is for beta. So now we have beta over 2, so we divide everything by 2 here, okay, to consider the interval here. So this is just going to be 0. This will be beta over 2, and this is just going to be pi. Okay, so essentially what I'm looking for here is I'm looking for where beta over 2, sine of that guy, would be square root of 2 over 2. Now, in this particular case, if you think about square root of 2 over 2 in terms of sine, if you go to your unit circle, you can see in quadrant 1, you have square root of 2 over 2 here with pi over 4 in terms of radians, or 45 degrees with degrees. And then you would want a 45-degree reference angle in quadrant 2, okay? So in terms of degrees, that's going to be 135 degrees, or 3 pi over 4 in terms of radians, right? So right here, okay? And you can see this right here. Okay, so that's pretty obvious, and you can see that that falls in line with our interval for beta over 2 because it's from 0 to pi, okay? So we're going to take pi over 4 and 3 pi over 4. So I'm going to say that the sine of pi over 4 is equal to the square root of 2 over 2, and also that the sine of 3 pi over 4, okay, is equal to the square root of 2 over 2. Okay, so what I want to think about here, now that I have everything set up, remember, you can set these guys equal to each other because I know that the sine of pi over 4 is equal to the square root of 2 over 2. And I know that beta over 2, sine of that guy, is equal to the square root of 2 over 2. So what I can do here is set up a little equation so that I can solve for beta, right? So let me do this over here. I'm going to say that beta over 2 is going to be equal to pi over 4. Because again, sine of this guy produces this, and sine of this guy produces this. So I can set these two equal to each other in order to get a solution for beta. Okay, so that's why that's going on. Okay, so let's scroll down just a little bit to get some room. I'm going to put or here. I'm going to do the same thing with this. So beta over 2 is equal to the 3 pi over 4. Okay, and all I need to do here, it's very simple to get a solution. I'm just going to end up multiplying both sides by 2. Okay, so this is basically going to be what? This is going to cancel. I'll have beta is equal to, the 2 would cancel the 4 and give me a 2 down here, so pi over 2. And then over here, basically I'm multiplying both sides by 2. And so this is going to cancel, and this is going to cancel, give me 2 here. So we'll say, or beta is equal to my 3 pi over 2. Okay. So these are our two solutions in terms of radians, and they're within our domain or our restrictions. So I'm going to do this in solution set notation. So I'm just going to put pi over 2 and then comma 3 pi over 2, okay? So we're not asked for the general solution here, so we don't need to worry about that. If you were asked for the general solution, remember your period here is different because you're dividing by 2. So basically the period here is 4 pi, okay, not 2 pi. Okay, so you got to remember that. All right, so one thing I want you to do is pause the video, go ahead and plug pi over 2 in for beta in each case, and verify that basically these solutions do work. You can just do one of them. I'm going to just say, trust me that they both work, but just pause the video and see that for yourself, that if you plug in pi over 2 right here, okay, so you have pi over 2 divided by 2, and right here, pi over 2 divided by 2, that basically you would get a true statement. The left side would be equal to the right side. Okay. Let's take a look at another example. So this one is slightly more complex. Not more complex, but more tedious because you do need to use an identity and then there's some squaring involved. So we have the negative cosine of theta is equal to negative 2 plus 3 times the sine of theta over 2. Again, when you think about these things, if you end up with cosine and then sine, you're going to be thinking about an identity, right? So if I think about sine of theta over 2, if I go back to my handout on the identities, and we come down here, let's go all the way down to where we get to the half angle identities, and it was the last one we talked about. So here's the one for sine. So you have sine of a over 2. In our case, we're working with theta. So let's say sine of theta over 2 is equal to plus or minus your square root of 1 minus the cosine of theta over 2. Okay, so let's go back and let's just make a little replacement. Okay, so I'm going to put the negative of cosine of theta is equal to, I'm going to have negative 2. And then I'm going to have plus, you've got your 3 here that's multiplying this. So keep in mind that basically you have that plus or minus. I'm going to put this in front. So I'm going to do plus or minus like this, and then the 3, and then times that little guy, which was the square root of 1 minus the cosine of theta, and this was over 2. Okay, so all I did was I plugged in for sine of theta over 2, just using the half angle identity. Okay, that's all I did. Now, what I want to do here, remember, if you have a radical somewhere, you're going to end up having to square, okay? And in order to do that, you first want to isolate this guy, okay? So what I would do here is I would first add 2 to both sides, okay? And let's scroll down just a little bit. So I'm just going to say that I have 2 minus the cosine of theta is equal to, this is canceled over here, so I have plus or minus 3 times the square root of 1 minus cosine of theta over 2. Now I can square both sides, okay? So I can get rid of this radical. So I'm going to square this side, and I'm going to square this side, okay? When you square the plus or minus, you don't have to worry about it because basically you can think about this as negative 1 being squared, that's going to be positive 1, and a positive, you square it, it's still positive, okay? So you can basically forget about that. So over here, I'm going to use my special product formula and say it's the first one squared, so 2 squared is 4. And then minus, it's 2 times the first guy times the second guy. So 2 times 2 is 4. And then times cosine of theta, and then plus the last guy squared, so this is just cosine squared theta, okay? And we'll rearrange this in a moment. I know this is not how we usually write this. We'll put equals. Again, don't worry about the plus or minus, that's gone. 3 squared is going to be 9, and then it's multiplied by this guy right here squared. I'm just removing the radical, okay? So basically you have this 1 minus the cosine of theta over 2. Now be careful here because 9 is multiplying this whole thing, okay? If you end up distributing this to the numerator, make sure you use parentheses, okay? Very important. What I'm going to do first is rearrange things. So I'm going to put this as cosine squared theta, okay? Then minus 4 times cosine of theta, and then basically plus 4, okay? So I've got all my signs right. I want to make sure on that. And then this equals, let's do 9 times 1 minus cosine of theta like this, okay? Because the 9 is multiplying the 1 and also the negative cosine of theta. Then this is over 2, okay? So now what I'm going to do is I'm going to multiply both sides by 2 so that I can clear this denominator, okay? So basically this comes here and cancels here. And here I'm just going to put a 2, okay, being multiplied by everything there. So you'd have 2 times the cosine squared theta. And then I would basically have minus 8 times the cosine of theta. And then plus I would have 8. And this equals, the 2's canceled. So just let's go ahead and distribute this. So 9 minus 9 times the cosine of theta. Okay. So far, so good. Let's scroll down just a little bit more. Okay. So what I want to do here is basically subtract 9 away from each side of the equation. And also add 9 times the cosine of theta to each side of the equation, okay? So basically what this is going to do is give me a 0 on the right, okay? You can see where I'm going with this. I'm going to end up factoring and using the zero product property. So on the left, I have my 2 times the cosine squared theta. And then basically I have negative 8 cosine of theta plus 9 cosine of theta. So this is going to be plus cosine of theta, or you could say plus 1 times the cosine of theta, whatever you want to do there. And then basically 8 minus 9 is negative 1, and this equals 0. Okay, so the idea here is that, of course, if you wanted to, you could use the quadratic formula, but we have something that is factorable. So let me go ahead and cut this away, put that in there. So I'm just going to factor the left side here. Again, if you have trouble factoring this, I see a lot of students having trouble, write it as 2u squared plus u minus 1 equals 0. You can factor that no problem, right? You think about this as 2u and u, and then the last guy here is a negative 1, right? So that tells me I need mixed signs here. This guy is going to be positive. So what I want to do is put a plus 1 here and a minus 1 here, right? Because the outer would be 2u and the inner would be minus u, so that would give me the correct plus u there, okay? Now, once you've factored it like this, you just put your cosine of theta in for u, okay? So let's come back in here, replace this with cosine of theta, and your roadblock is gone. Okay, so 2 times cosine of theta there. Okay, so a little trick for you. Now, I'm going to set each one of these equal to 0 and solve. Let me just get rid of this. We don't need this anymore. So I'll say 2 times the cosine of theta minus 1 equals 0. Or I'll say the cosine of theta plus 1 equals 0. Let me scroll down and get a little room going here. So basically, I'm going to add 1 to both sides. And this is going to give me 2 times the cosine of theta is equal to 1. Okay, I'm going to now divide both sides by 2. And I get cosine of theta is equal to 1/2, okay? Over here, let me go ahead and put or, and I'll put or. And then over here, I'm just going to say minus 1 minus 1. So the cosine of theta is equal to negative 1. And I guess I don't really need another one there, so let's put this over here. Well, I guess I could write it down here. So cosine of theta equals negative 1. Okay, so you see what we're doing here. We basically have to solve this guy and then this guy. So where's cosine going to be equal to 1/2? Remember, cosine is positive in quadrants 1 and 4. And we know that cosine of 60 degrees, okay, is 1/2. So basically, you would want a 60-degree reference angle in quadrant 4. So that would be 300 degrees, right? So you'd want 60 degrees and then 300 degrees. Again, if you're still looking at your unit circle, it's no big deal, right? This is 1/2 here. So you see it's 60 degrees or pi over 3 in terms of radians. And then over here, you'd be in quadrant 4, so you have 1/2 here, 300 degrees or 5 pi over 3 in terms of radians, okay? So again, if you need to use the unit circle, keep doing it. You will memorize it eventually. Now, while we're down here, I might as well note that basically pi, okay, cosine of pi is going to give you negative 1. So let's go back up, and let me erase the degrees, and let me say that theta here would be equal to your pi over 3, and then it would be 5 pi over 3, and then it would also be pi, right? So this covers these solutions from these guys. Now, in order to make the video a little bit shorter, a little bit more concise, I'm not going to check these solutions. When you square both sides of an equation, we know from basic algebra that there's a possibility of extraneous solutions, right? Solutions that won't work in the original equation. I have already checked this. I know that these guys are going to work. I can say that the solution set here is pi over 3, okay? And then I'll say pi, and then I'll say 5 pi over 3 like this, okay? So these solutions do work in the original equation. In the next example, we'll see where it doesn't, okay? So let's go to that now. All right, let's look at another example here. So we have the square root of 3 times the cosine of theta over 2 is equal to 1 plus the cosine of theta, okay? Again, same interval from 0 to 2 pi, 0 is included. Again, if you see something like this, you have cosine of this and cosine of this, well, you can go ahead and use your identity. So we come back here. Now, cosine of, in this case, would be theta, theta over 2, is plus or minus the square root of 1 plus the cosine of theta over 2. So let's just make a little substitution here. I'll say the square root of 3, okay, and I'll put the plus or minus out in front of here, then times my square root of 1, in this case, it's plus the cosine of theta. Remember, if it's sine, then it's minus. If it's cosine, it's plus. And then this is over 2. And this equals your 1 plus your cosine of theta, okay? So again, all I need to do here is just square both sides. So let's square this side, and let's square this side, okay? And over here, the plus and minus, forget about it, it's gone. Square root of 3 squared is 3. This guy, if I square it, I'm basically going to end up with the radicand. So this is 1 plus the cosine of theta over 2. And to speed this up, let me just wrap this in parentheses and put this like this. And let's put equals over here. I'm going to flip these. I'm just going to put the cosine of theta plus 1, so it makes it easier. So cosine of theta plus 1 like this. So this would be the cosine squared theta, first guy squared, plus 2 times the first guy times the second guy. So it's basically just 2 times cosine of theta, and then plus the last guy squared, so that would be 1, okay? So over here now, all we need to do is basically multiply everything by 2, right? So this would cancel. Let me show this visibly. And let's go over here and do this. So now I have 3 times 1, which is 3, plus 3 times the cosine of theta. And this equals 2 times the cosine squared theta, plus you'd have 4 cosine, and I messed that up. So cosine of theta, and then plus 2 times 1 is 2. So from here, because I have a squared term, I want to think about either factoring or using the quadratic formula. This one's going to be factorable, so we'll be safe there. Basically, let's move everything to the left because that's where I like it. So let's subtract 2. So basically, this is going to be 1. Let's go ahead and subtract 4 times the cosine of theta. So minus 4 times the cosine of theta. So this is going to be negative cosine of theta. And then let's subtract 2 times cosine squared theta. So I'm running out of room over here. So let's just kind of put this over here. So minus 2 times cosine squared of theta. I know this is kind of getting a little messy, but let's just write it neatly now. So we'll put this out in front. We'll put negative 2 times cosine squared theta. And then we'll put minus cosine of theta. Then we'll put plus 1. And of course, everything's gone from over here, so this equals 0. If you want, for factoring, a lot of people do not like to factor with a leading coefficient that's negative. You can multiply everything by negative 1. So this becomes positive. This becomes positive. This becomes negative. And it has no effect on 0. Okay? So basically, if I want to factor this, again, you can use that trick with u if you want. I don't really need to do it. So I'm just going to put 2 times cosine of theta and cosine of theta, okay, because this times this would give me this. Now, the final guy is negative 1. So that can only come from positive 1 times negative 1. We know that this guy right here is positive, so that means I want to put plus 1 here and minus 1 here, right? Because the outer would be 2 times cosine of theta, the inner would be minus cosine of theta, so that would combine to give you this, okay? So let's go ahead and copy this and paste this in another sheet. And again, I'm just going to use my zero product property. I'm going to say 2 times the cosine of theta minus 1 equals 0. Or the cosine of theta plus 1 equals 0. So I'm going to add 1 to both sides over here. And I'll have 2 times the cosine of theta is equal to 1. Divide both sides by 2. And again, we get this cosine of theta is equal to 1/2. So we already know that that's going to occur basically at 60 degrees, right? Or a reference angle of 60 degrees in quadrant 4, which is 300 degrees. Let me just drag this up here. We'll say that theta here is 5 pi over 3, or actually let's do this first. So we'll do pi over 3, or then 5 pi over 3. So again, this guy right here is your 60 degrees. This guy right here is going to be your 300 degrees. Okay, so then or, okay, and I'll just put a comma here. For this one, it's really simple. I just go minus 1 here, minus 1 here. So we have the cosine of theta is equal to negative 1. We already know this is going to be pi. Okay, so we've seen this before. So this is exactly the same solution that we got in the last section or the last example, but basically now you're going to see that one of them is not going to work. So let's actually erase all of this. We know it's a pain to check solutions, but it's absolutely necessary in this case. So my original equation is the square root of 3 multiplied by the cosine of theta over 2, okay? And then basically you have is equal to 1 plus the cosine of theta. So what do I have here to start? Let's go square root of 3 times, you would have the cosine of, basically you would have pi over 3 divided by 2. So it's like multiplying by 1/2. So it's the cosine of pi over 6. And the cosine of pi over 6, remember pi over 6 is 30 degrees, so that's going to be square root of 3 over 2. So let me just write this over here for reference. So cosine of pi over 6 is square root of 3 over 2, okay? So let me erase this, and I'm going to put square root of 3 over 2. This equals 1 plus the cosine of theta. In this case, we're working with our pi over 3. Let me write this in. So the cosine of pi over 3. And we already know that this is 60 degrees here. So this would be 1/2, okay? So what is 1 plus 1/2? Most of you know this would be 2 over 2 here. So 2 over 2 plus 1 over 2 would be 3 over 2, or basically 3/2. Now, if I do square root of 3 times square root of 3, that is 3, okay? So this does give me 3/2. So the first solution is valid. So this one you can put a big fat check, okay? The next one you're going to see a problem with. So let's go ahead and erase this and try again. So we have the square root of 3 times, I'm putting 5 pi over 3 in here. Remember, if I do 5 pi over 3, let me erase this. We're not going to need this anymore. So if I do 5 pi over 3 and then divided by 2, it's like having cosine of 5 pi over 6. Now 5 pi over 6 is 150 degrees. So that has a 30-degree reference angle, and it's in quadrant 2, so it would be the negative of the square root of 3 over 2, okay? So this is the negative of the square root of 3 over 2, okay? Over here I have 1 plus the cosine of 5 pi over 3. And we already know this is going to be a half, right? So we know this is a half. This ends up being 3 halves. And you can see this is not going to work out because of the sign, right? Square root of 3 times square root of 3 is still 3. But now it's going to be basically negative of 3 halves equals 3 halves. So this is false, right? This does not work. So this is what I mean by checking the solutions. If you don't check them, there's a chance, it's not going to happen every time, but there's a chance that you report a wrong answer, okay? Something that doesn't work in the original equation. Now this last one's going to work. If I put a pi over 2 in here, remember pi over 2 is 90 degrees, and cosine of 90 degrees is 0, right? So if I did square root of 3 times 0, well, that's 0, right? So you can basically say this is 0 over here. And then on this part, I have 1 plus the cosine of pi, and the cosine of pi, or the cosine of 180 degrees, is going to be negative 1. So what is 1 plus negative 1? That's going to be 0. So you get 0 equals 0. So this one checks out as well. Okay. So let's go ahead and erase this and we can finally write our solution set. I know this is super tedious, but it's just something you have to do. So we end up with pi over 3. Okay. And then we end up with pi. These are the only two solutions in the interval we're given, from 0 degrees, or from actually 0 in terms of radians, out to 2 pi in terms of radians. So 0 is included, 2 pi is not.